Hello, I'm Dr. Steve Warner, and today I'm going to talk about the basic trigonometry of the right triangle. Let's look at a right triangle, and let's focus on one angle, say the angle A. If we're focusing on A, then the opposite side to A is the side BC, and the adjacent side to A, the one right next to A, is AC. Notice that we chose AC instead of AB for the adjacent side because the side opposite the right angle is always called the hypotenuse. We can now define the three basic trigonometric functions of the angle A. The sine of A is opposite over hypotenuse. The cosine of A is adjacent over hypotenuse, and the tangent of A is opposite over adjacent. Many students find it helpful to remember the word SOHCAHTOA. This is just a mnemonic device for remembering that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. More advanced students might also want to remember the reciprocal functions. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So notice that since sine A is opposite over hypotenuse, cosecant A is hypotenuse over opposite. Cosine of A is adjacent over hypotenuse, so secant A is hypotenuse over adjacent. And tan A is opposite over adjacent, so cotan A is adjacent over opposite. To help remember which is the reciprocal of which, it's pretty easy to remember that tangent and cotangent are reciprocals, since they both have the word tangent in them. The secant and cosecant are a little trickier. The way I remember it is that the S always goes with the C, as opposed to the more natural C going with a C and an S with an S. So sine goes with not secant, but sine goes with cosecant, and cosine goes with secant. They're reciprocals of each other. Okay, as a simple example, let's look at this right triangle and compute all 6 trig functions for each of angles P and R. Notice that we would never do angle Q because that's the right angle. So the sine of P is opposite over hypotenuse, so that's 12 over 13. Cosine of P is adjacent over hypotenuse, so that's 5 over 13. And tan P is opposite over adjacent, so that's 12 over 5. Now, the other three here, cosecant, secant, and cotangent, are the reciprocals of sine, cosine, and tangent, respectively. So cosecant P is just the reciprocal of sine, so it's 13 over 12. And secant P is the reciprocal of cosine, 13 over 5. And the cotangent of P is the reciprocal of tangent, so it's 5 over 12. And now let's do the same thing for R. Hopefully you have the idea, so I'll write these out just a little more quickly. 5 over 12. Cosecant R is 13 fifths, and here I'm just taking the reciprocals of the other three, 12 over 5. Okay, let's look at an example. In the right triangle pictured below, A, B, and C are the lengths of its sides. What is the value of cosine A? Well, cosine of A is adjacent over hypotenuse, B over C, and that is choice E. In many trigonometry problems, the Pythagorean theorem may need to be used at some point. Recall that if a right triangle has legs of length A and B and hypotenuse of length C, then C squared is equal to A squared plus B squared. It's also helpful to know the following Pythagorean triples. although it's not necessary. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. If you know these triples, you can avoid actually going through the steps of the Pythagorean theorem in many cases. If you don't know them, then you'll just have to take an extra few seconds to perform the Pythagorean theorem. Let's look at an example. If x is between 0 and 90 degrees and cosine x is 5/13, then tan x is what? Okay, to solve this problem, let's draw a right triangle and pick an angle for x. Now, we're given that cosine x is 5/13, so that's adjacent over hypotenuse. And now I use the Pythagorean theorem, or better yet, recognize that this is a Pythagorean triple, 5, 12, 13, to get the other side of the triangle. Finally, tan x is opposite over adjacent, so that is equal to 12/5, which is choice D. Let's try another example. The figure below shows a right triangle whose hypotenuse is 4 feet long. How many feet long is the shorter leg of this triangle? Okay, so we're looking for the shorter leg of the triangle, which is this one. So we know the hypotenuse, we know the angle of 60 degrees, and we're looking for the adjacent side. So we're going to use cosine. Cosine of 60 degrees is equal to adjacent x over hypotenuse 4. Multiplying each side by 4, or if you like, you could put this over 1 and cross multiply, whichever you prefer, we get x equals 4 cosine 60 degrees. Well, the cosine of 60 degrees is a half. You can get that right in your calculator if you want, and I'll show you another way in just a moment. And finally, 4 times a half is 2, so that the answer is choice A. It's definitely useful on the ACT or other standardized tests to know the special 30, 60, 90 triangle shown here in the box. For example, in this problem, note if we just let x equal 2, then we could see that the other sides of this 30, 60, 90 triangle are 2 for x and root 3 times 2, or better yet, 2 root 3 for the side opposite the 60-degree angle. Since we want the shorter side of the triangle, or the shorter leg of the triangle, the answer is 2, choice A.